tokens. Mixture of tokens is a name that comes from mixture of experts. It's a very well-known technique. Even in the recent past, there have been rumors that GPT-4 or what OpenAI is serving as GPT-4 could be mixture of experts, where separate parts of your token would be sent to separate experts based on what it is. And the model might be actually an expert based, like a mixture of expert model. So what mixture of token is trying to do is efficient LLMs through cross example aggregation. So first, the authors of this paper are trying to explain what is the problem with mixture of tokens or mixture of experts, MoE. So they're saying that the existing MoE technique can lead to training instability and uneven expert utilization. So basically you have to match the token with an expert that can actually lead in that case tokens could be discrete, and because of that MoE models are prone to training instability and uneven expert utilization, so where every model does not get the right input. So because of that, they are proposing a new technique called mixture of tokens, which is a fully differentiable model that retains the benefits of mixture of expert architectures while avoiding the difficulties that were discussed before. So rather than routing the tokens to the expert, imagine you have like 10 experts, you have to now find the token and match it with the expert and route it to them. This approach mixes tokens from different examples prior to feeding them to experts, enabling the model to learn from all token experts combinations. Importantly, this mixing can be disabled to avoid mixing of different sequences during inference. Crucially, this method is fully compatible with both masked and causal large language model training. So masked is like somewhere like BERT, where you have got a large language model that is trained with the masked data in the middle, so it has to fill in data there. And the causal model is what we basically are using, like ChatGPT, to generate text. So this is the paper. I found it quite fascinating because this is an area that I feel that not a lot of people are actually spending time on. And you can go here and then see, for example, mixture of experts in the left. You can see then you have like the first feed forward layer in the neural network, the second feed forward layer in the neural network. You have got these tokens going here, but in the mixture of tokens, you can see that the token gets mixed up. It goes in there and it goes and it goes to this all these experts, and you get the final result by an expert feed forward layer. That's what you see here, an expert feed forward layer. Interesting paper, definitely check out. The next one is JudgeLM. JudgeLM, nothing to do with the legality, nothing to do with law at all. The first time I heard this name, that's what came to my mind. Fine-tuned large language models are scalable judges. What if you can have a large language model as a judge for these large language models? That's exactly what this paper is exploring. It's from Beijing Academy of Artificial Intelligence, School of EIC, Huazhong University of Science and Technology. The code and models are available here. So basically the problem is, what they are trying to say is, okay, it is challenging to measure large language models or evaluate large language models because existing benchmarks and metrics cannot measure them comprehensively. We have seen data leakage issues, contamination issues, and a lot of other these issues. So what they are suggesting is they train a JudgeLM, a new model that's called a JudgeLM, Judge Large Language Model. And this Judge model is introduced with a couple of techniques like swap augmentation, reference support, reference drop, and they just want to increase the judge's performance. The main thing here is that if you see the JudgeLM, what they're saying is efficient. JudgeLM 7 billion parameter model needs only 3 minutes to judge 5,000 samples with 8 A100s. Now, if you're watching this channel, you might be wondering, is it efficient? Because you need 8 100 GPUs. Anyways, this is for people who have got. And this judge model also happens to have high agreement with the teacher judge, achieving an agreement exceeding 90% that even surpasses human to human agreement. It's actually like an interesting concept. You can see probably like when you use simply GPT-4 as like an out-of-box judgment, like a zero-shot judgment, you can say identify the words that are used as modifiers, and you give she drove her green car quickly, and you've got all these models, and then you get the answer 1, answer 2, and you use GPT-4 as a judge or a judgmental model to judge this, and it gives you a score of 1,10. The first one says assistant 1 did not provide any answer to the question, hence the low score. And now what they are exploring is, okay, how can we have like this judge model that can give us proper reason why it has been scored like that, and also it can give you the responses. This can be extremely helpful in scaling up fine-tuning efforts, scaling up alignment efforts, and you can see like what is the question, what kind of answer it gives, what kind of second answer is, and what is the ground truth, and how the judge has outputted, like how the judge has given the judgment score. Okay, answer 1 score is 10, answer 2 score is 1, and it gives you a detailed response of how or why it gave a particular score. The next paper that we want to look at is an emulator for fine-tuning large language models using small language models. Almost the similar group, I'm not sure if every name, but most of them are also part of the DPO, direct preference optimization technique, that has been used for Zephyr model, the fine-tuning process or the alignment process. It's the same group of researchers from Stanford University, and what they are trying to do here is, can you use a smaller model and combine it with a larger model? And later in this video, we would actually see models where people are merging or combining these models. Let's say you've got a small scale model, and that goes through a pre-training, that goes through a fine-tuning. Let's say you've got a very large model, like a 70 billion parameter model, that goes through pre-training, that goes through fine-tuning. So you know A plus B is equal to Llama 2 7 billion chat model. C plus D equals Llama 2 70 billion chat model. What happens if you combine A plus D and C plus B? That's exactly what they are calling as emulated fine-tuning, or EFT. So the emulated fine-tuning is a reinforcement learning based framework, and they're using this to get these they're using this to actually see, can we use the pre-trained knowledge from the large model with the fine-tuning skills that the model acquired from a smaller model, and combine these two and then get some better result. And you can see how that has helped them, and the method that they've used is called LM upscaling, that is to avoid resource intensive fine-tuning of large language models. And they have figured out that upscaling consistently improves the helpfulness and the factuality of instruction following models in Llama, Llama 2, Falcon models without any new hyperparameters or training at all. This is EFT, emulated fine-tuning, where ideally they are trying to combine the skill or the technique that the smaller model learns in fine-tuning with the knowledge, the factuality that the larger model has got. And we'll actually see another paper on a very similar line, so just keep that in mind. This has got a lot of details about, you know, how the results have been on helpfulness and factuality. Definitely go check it out. But once again, this crowd, like the authors, the research authors of this paper, seems to be quite interested in scaling up the alignment efforts. So kudos to them for releasing these papers. The next one is ConvNet's match vision transformers at scale. Before everybody started talking about AI, artificial intelligence, before even ChatGPT, there have been like a lot of deep neural network architectures that have existed for a very long time, starting from MLP, multi-layer perceptron. Hopefully I'm saying it correctly. There have been like a lot of neural networks. One of the most successful neural network architectures have been ConvNets or CNNs. So these neural network architectures, people have almost thought like, you know, they don't exist anymore. They don't survive in this world of transformers architecture. But Google is trying to prove you otherwise. Google DeepMind has released a paper that says ConvNets match vision transformers, especially like WIT models at scale. So you can have ConvNet and then make those models as good as vision transformer model, even at scale. And the strongest fine-tuned model that they've got achieves a top 1 accuracy of 90.4%. It's once again like a very interesting aspect of how still researchers are saying that, okay, I don't want to just rely only on transformers. I want to find different ways. We have seen time and time again different models like RNN models making a comeback, Raven model, and it's good to see CNN making a comeback. I think this will open up the research space because a lot of people are quite familiar with CNN, and that will give them the ability to create new things. Forget about just transformers. You can use ConvNets and really come up with like good accuracy and get good result on vision transformers. The next paper that we're going to discuss today is Zephyr direct distillation of large language model, or LM alignment, language model alignment. It's from this Hugging Face team called H4. H4 stands for helpful, honest, harmless, huggy team. Okay, anyways, this is the whole aim of this group is to have a smaller model that can produce great result. We have seen Hugging Face's Zephyr 7 billion parameter alpha model. We have seen Zephyr 7 billion parameter beta model. And this is like the technical report of how they went about building that model and what kind of details are available here. And just I want you to go through this paper because one, this does not use the traditional reinforcement learning technique that people have been using for alignment, which is reinforcement learning from human feedback, RLHF. Rather, it uses something called direct preference optimization, which we just discussed, like these authors were covering, the authors from Stanford University. So definitely go check out that. And the good thing with Zephyr is it's a smaller size model, requires lesser time for training, the number of hours. So you spend less money, spend less cost, less compute, and you probably end up getting better model. I think whether it is better is still a subjective question, but we have seen in a lot of tasks, and I have personally heard from a lot of people that these models are really good at the tasks that they are good at. They're not good at math coding, and that's something that the community would try to solve it. But at least, like, if we have got the secret sauce to build quality models with lesser compute with smaller models, I think this is like a great win for the whole large language model space. So they have got like extensive details about, okay, what is DSFT and how are they going to do a DSFT. In this case is SFT stands for supervised fine tuning. DPO here stands for direct preference optimization. So they have given all the details about how they went about dataset preparation, how they went about training the model, how they went about ranking the responses, and finally distilling the model in itself. So the next one is called hyperfields towards zero shot generation of NeRFs from text. This is slightly different from whatever we have seen. This paper focuses on generating NeRF, NeRF. NeRF stands for Neural Radiance Fields. Neural Radiance Fields. I don't know if you have seen, like, there are a lot of demos. Like, if you happen to use any iOS device, there is an app called Luma Labs where you can just take the iPhone or an iPad and then shoot something, and that will actually generate a neural radiance field, NeRF, which gives you ultimately an ability to like create a drone shot. It's quite fascinating. I'm not like fully familiar with the technology in itself, but what this paper that is from Toyota Technological Institute at Chicago, University of Chicago, is trying to do is trying to take user text and like how Stable Diffusion creates images, they are trying to create NeRF, the neural radiance fields from that. They have tested it with a bunch of things. So you can see hyperfields is capable of generating in distribution scenes unseen during training in a feed forward manner, the second column in this case. And for unseen out of distribution prompts, hyperfields can be fine-tuned to yield scenes respecting prompt semantics with a few gradient steps. You can see out of distribution, training on multiple prompt, and in distribution inference. So this is again the reason I decided to cover is that we focus a lot on text to text. Sometimes we focus on text to image. We have already covered text to 3D and audio, video, and all the other aspects. This is one more that modality or medium that is NeRF, and a lot of people are fans of NeRF, and it seems like a good effort to see people are creating research papers around generating NeRF from the text. That is what hyperfields is about. Next one is from Microsoft, and this is called KITAB, evaluating large language models on constraint satisfaction for information retrieval. The title is actually, I don't know, like I didn't find the title quite relevant to what the paper is. But anyways, but I strongly appreciate the effort, which is to say they want to study the abilities of the models to answer constraint satisfaction questions for information retrieval. For example, you say, give me a list of ice cream shops in San Diego. So now you have specified a constraint for this large language model to answer from this particular constraint. To study that, they have actually introduced a new data set called KITAB. And I think in Arabic, in Hindi, KITAB means book. So this data set is actually about books. And you can access the data set here on Hugging Face's dataset hub. You can go see what are the columns available. You've got information like author, author's birth year. On the other informations, you have got the training and test. You have got like book, once again, author, birth year, site links, constraints, mapped books, all books, raw books. So this paper introduces this data set, which can be ultimately used to evaluate how the large language models perform in a constrained satisfaction manner for information retrieval. And you can see how the model is performing and all the other informations, especially like when you want constrained queries. Like for example, you can ask list, or if you want to ask a question like list all the books written by Toni Morrison, born in 1931, that were first published between 1970 to 1980. So you have got an author constraint, you have got a book constraint, and so you expect the model to respect these constraints and then answer the question. So it's an interesting paper and an interesting data set if you want to use this for any fine-tuning purposes. The next paper, AlpaGasus, am I pronouncing it right? Training a better alpaca with fewer data. So that is the name of the model. Fine-tuning a large language model, not on all data. I think time and time again, this is one thing that we have been noticing, whether it is Phi, whether it is Zephyr, whether it is a Mistral 7 billion parameter model. I think synthetic data plays a huge, like highly focused, high quality synthetic data plays a huge role. And that's what this paper is going into. And that's one of the reasons like why I wanted to cover this paper, because I wanted to say that, okay, I have a lot of fine tuning videos, to be really honest. And if you were to build a quality model, as long as you follow some fine tuning process, you will get a model at the end of the day. But to make sure that the model is really good, it has good purpose, you need to have high quality data set. And it's not about having the format or anything. It's about having the data in itself. And that's what this paper is saying. How they took an existing data set, filtered it, that gave them faster training, reducing the training time, the money, and ultimately the model is also better at multiple diverse data sets and tasks. And that's what this paper is. Go through the list and then see how they are utilizing existing models to create this generation. And we have also seen JudgeLM just a couple of minutes before, which is also kind of trying to do this thing. It's trying to judge the output from LLMs so that you can use that for probably like, let's say, fine-tuning purpose. So that is AlpaGasus. The next paper, fine-tuning aligned language models compromises safety even when users do not intend to. We jailbreak GPT 3.5 Turbo safety guardrails by fine-tuning it on only 10 such examples at a cost of less than 0.2 via OpenAI's API, making the model more responsive to nearly any harmful instructions. I think this is the key of this. So simply fine-tuning with benign and commonly used data sets can also inadvertently degrade the safety alignments of LLMs. A lot of these alignments happen when the pre-training finishes, but this paper shows that you don't need like fancy jailbreaking techniques. Sometimes just simply fine-tuning with a bunch of data can actually lead to jailbreaking this model. I think this also goes back to what kind of training data set goes inside the pre-trained model, because time and time again we have seen that pre-training data feeds factuality and knowledge into the model in itself, while fine-tuning can bring out the best, like the format, the steerability, the style from the data set that was part of the pre-trained process. So this is one more great example to see that it doesn't take like a huge genius to break these large language models. And even as a matter of fact, breaking large language model itself could be actually a difficult thing to say, because these large language models are going to be more prone to be broken, and that's why they have like this red teaming effort. And that's one reason like I am like a strong advocate for open source, to say that okay, if future is going to be defined by these models, at least let's open it up. Of the day is called feasibility of using privacy preserving large language models like Vicuna in this case for labeling radiology reports. The purpose to test the feasibility of using an alternative LLM that can run locally for labeling radiography reports, and the result is quite fascinating and stunning. Of a total of 3,265 reports, blah 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 blah, you can see Vicuna outputs with prompt 2 showed on average moderate to substantial agreements with labelers. Just basically says at the end of the day that if you see Vicuna performed on par with the labelers that they have got the Shea expert. So in this proof of concept study, outputs of LLM Vicuna reporting the presence and or absence of 13 findings on chest radiography reports showed moderate to substantial agreement with existing labelers. My trustworthiness about the medical domain pharma industry is quite low, especially recently, there is a movie that has come. It's called Pain Hustlers, I guess. So after seeing these kind of movies, you don't trust these systems much as you do before. So you always need somebody who does not have bias, somebody who does not have that vested interest to make more money out of you, to vet it and then tell you. I'm quite happy that we have got these AI solutions, or at least I'm happy that people are trying out these AI solutions that can play that kind of role. And that is what this paper is about. So using Vicuna for labeling radiology reports, and it has got an improvement or a moderate to substantial agreement with existing labelers. It's a good thing. You just don't need human beings for everything, which is a good thing. So the next paper is called QMoE, practical sub 1-bit compression of trillion parameter models. Mixture of experts architecture offers high inference cost of large language models via sparse routing, bringing faster and more accurate models at the cost of massive parameter counts. For example, this model, has got 1.6 trillion parameters, requiring a 3.2 billion of accelerator memory to run efficiently, which makes it practically impossible to deploy. That's where a new technique comes in. It's called QMoE. It consists of a scalable algorithm which accurately compresses trillion parameter MOEs to less than 1 bit per parameter in custom format code designed with bespoke GPU decoding kernels to facilitate efficient end-to-end compressed inference with minor runtime overheads relative to uncompressed execution. So bottom line, if I want to tell you in one line, these large language models, people are exploring different ways. One of the ways is MOE. This is like a quantized version of MOE. That's what it is trying to do. QMoE is trying to compress this large trillion parameter models with sub less than 1 bit compression. And whenever we quantize, we do like 4-bit quantization, 8-bit quantization, 5-bit quantization, 2-bit quantization. So this is like sub 1 bit. This ultimately enables for the first time execution of a trillion parameter model on affordable commodity hardware like a single server with 4x A6000 or 8x NVIDIA 3090s at less than 5% runtime overhead relative to idle uncompressed inference. And they've shared the code as well for you to go check it out. It's an interesting approach. The hyperlink had an issue. It's an interesting approach if you want to see how to, like for example, let's say you want to start a competitor that has to run these large language models at a huge scale, and you don't want to always scale up your hardware. I think this kind of approach really helps. I've not tested or tried it out how to see how efficient the model is, but the idea is good. It's a good thing that people are trying to figure out ways to run large models on smaller clusters of GPUs, and QMoE is one of those techniques that can help you compress trillion parameter model into sub 1 bit compression. The next section we're going to discuss about models, and the first model that we want to talk about today is Zephyr 7 billion beta model. I've got a separate video. I've got some constructive feedback saying that, hey, why did you say that just challenges OpenAI or ChatGPT? Just want to say that this model has got a really good score when you compare it with GPT 3.5 Turbo. So you can see this is like the yellow color one, and on like a bunch of tasks like writing, humanities, STEM, this model is doing on par with GPT 3.5 Turbo, and that is something that you can actually see here as well. So this model without RLHF, this model without massive amount of data, just a 7 billion parameter model that you can just run on free Google Colab. This model is scoring really good, and that's why I said like this is an approach, this is a model, this is a path that could challenge OpenAI or ChatGPT, and I would strongly encourage you to test out this model and then let me know. One important thing is this model boosts performance on empty bench. That means it has been designed for multi-turn chat, like not just like question and answering, but you have like multiple communication. Definitely check it out. It's from the Hugging Face H4 team, and this is the second model in the Zephyr series. The first one was alpha, the second one is beta. Made a huge improvement over like really large models, and being appreciated by a lot of people. So the next two models that we are going to talk about actually came from one of our subscribers. I was quite proud and happy to see one of our subscribers creating this kind of high quality model. So kudos. Model name is Narwhal Mistral 7 billion parameter model. It is a model that is a merge of two models. The first model is a merge of Eric Hartford's Dolphin 2.1 and Hugging Face's Zephyr 7 billion parameter alpha model. The second one, which is the version 2 of the same thing, has got three models. It's a merge of Dolphin 2.1 with MetaMath Mistral and also the Zephyr 7 billion beta model, not the alpha model. It doesn't have any benchmarks, but I actually heard from the creator of this model that this model is doing really good. We all know that already Dolphin was good, and we all know that Zephyr was good. And I think if you remember this chart we just saw, Zephyr was not like a great model for math and coding. I'm not very sure if this model, which has been merged with MetaMath, changes that. But ultimately, this is a direction that I would love to see, where it's like a kid's color mixing exercise. You just take a couple of colors, mix it, and then you get a new color. Maybe you're excited about it. It has its own purpose. And I'm happy to see that people are doing this. I would definitely love to see more of it. And I'm planning to do an extensive test of this new model, which is Mistral Narwhal 7 billion V2. In the next section, we're going to see a bunch of open source projects starting from GradioLite. GradioLite is serverless Gradio running entirely in your web browser. Gradio is a very popular technique to run machine learning applications, deep learning applications. Most of the demos that you see on Hugging Face Spaces are Gradio. I have had like in the past like a dedicated course for Gradio. So Gradio has got now a serverless version thanks to WASM WebAssembly, which is powered by Pyodide, or I should say thanks to Pyodide, which is powered by WebAssembly. So technically all the libraries that are supported by Pyodide will be supported by GradioLite. That means without having like a dedicated server, which is what Gradio, the main Gradio does, you can just simply use GradioLite to create machine learning applications like web applications that can be, let's say, embedded on a blog post, that can be embedded on a GitHub README page. And you don't need server. You can just literally put this wherever you put an HTML file. I have had like in the past created like a dedicated complete free course for PyScript. I have got a huge playlist for it. So this joins like the similar family where you have got a light version like Streamlit Lite, which is completely run on the client browser, nothing to do with server at all. I think the only thing it does is it downloads the Python libraries at the start, but other than that, everything is happening at the client end, nothing to do with server. You don't need even a server to run it. Very happy to see this. Definitely looking forward to try it out. The next open source project, a not very new one, but recently got updated, is called RLMRec. So what this is doing is it's an implementation, a PyTorch implementation of another paper called RLMRec, which is called Representation Learning with Large Language Models for Recommendation Engine. This world has a lot of recommendation engine problem. Go to Netflix. Netflix always tries to keep you on their platform by showing the next best content for you. You go to food delivery website, they want to show you the best food that you would click and order it. You go to YouTube, people like me, YouTubers, have a difficult time in figuring out how YouTube is going to recommend our video or what is going to happen. So recommendation system, Rex systems are a bigger problem, like makes a lot of money for these big companies. So what this paper is trying to do is it's trying to say that why don't we use large language models for recommendation? So for example, you can see here based on this picture that you use large language models to do item collaboration or item profile generation, and you do large language model for user profile generation. A very popular recommendation engine system technique is called collaborative filtering. You need item to item user mapping or user to user mapping. So basically, like you can say that, hey, I like this Logitech mouse, so probably there is a good chance that I would like some other Logitech product. So this is like based on some other user, you come up with something, or based on some other item, you come up with this thing. So here they're saying that you should use large language models to create these profiles, and then use techniques, the existing techniques like contrastive alignment, generative alignment, to understand the combination and then finally generate the output, the recommended output for this. Very interesting one, because code is available. Two, because the recommendation engine is a recommender system is like an age-old technique, like starting from market basket analysis. People have been figuring out different ways. Using large language model for that is quite innovative, and let's see how the world of rexes with LLMs are going to move. The next open source project that I wanted to discuss is called Open Agents. I'm yet to try this. It's an open platform for language agents in the wild. That's a very wild name. But if you see this, the idea here is that, okay, can you have like an easy to use interface, easy to use framework system project to create agents, and that's what this project is trying to do for you. You like it can. It has got a couple of examples at this point, like a data agent for data analysis with Python and SQL, a plugin agents with 200 plus tools, a web agent with autonomous web browsing. And if you kind of see this thing, this is all the three components that are available in OpenAI's ChatGPT plus subscription for GPT-4. This is like advanced data analysis, or whatever they call as code interpreter, plugins, and the web agent for LLMs with internet. So open agents can analyze data, call plugins, control your browser, but with open code. So it has got all the things like easy deployment, full stack, chat web UI, agent methods, and all the other things. And it gives you like a lot of information about how you can set it up for yourself. Definitely one of my list to actually do hands-on and try this out. But I thought like, okay, meanwhile, let me mention it in the news. So if you were to try this out, let me know in the comment section, how do you feel about it, so that, I can share that feedback with the broader community. So the next section is going to be 3 general AI news. The first one is from OpenAI. They recently put out a blog post saying frontier risk and preparedness. Okay. What does it even mean? It's, yeah, from the title, you don't understand anything. What they're saying is, okay, as part of our mission for building safe AGI, we take seriously the full spectrum of safety risks related to AI, from today's systems to the furthest reaches of superintelligence. I appreciate OpenAI, but I don't know why OpenAI always thinks like, they're the police of the entire large language model or the AI world. Okay, maybe it's a US based company, that's what America does it. So no offense. So in July, we joined other leading AI labs, making a set of voluntary commitment to promote safety, blah, 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 blah. And if you see, why are they doing preparedness? How dangerous are frontier AIs when put to misuse both now and in the future? How can we build a robust framework for monitoring, evaluation, prediction, protection against dangerous capabilities of frontier AI? If our frontier AI model weights were stolen, how might malicious actors choose to leverage them? Great. This is great. So these are the things that they're trying to explore. So for that, they're putting together a preparedness team. And the reason why I wanted to cover this is, okay, one, like I need to make awareness about it. Two is you've got approximately $25,000 in API credits for the top 10 submissions. So if you happen to figure out what kind of catastrophic misuse can happen with these models, so you can go here and then sign up yourself, your name, last name, email ID, blah, 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 and specifically mention what kind of misuses that you have identified, and how you can join the preparedness team. It might give you an opportunity to work on OpenAI's preparedness team. But even otherwise, if you feel that AI is going to wipe out humanity, you might be the person, the John Connor, if I remember, you might be John Connor to save that happening. That is OpenAI's frontier risk and preparedness. I think the frontier models that they're talking about are like the cutting edge, the most advanced models than what is currently available, that can also, have emergent capabilities. And preparedness is how they are preparing for such a future to save the entire humanity. Thanks, OpenAI. Otherwise, I was scared. The next one is from Poe from Kung Fu Panda. That's what comes to my mind. Poe is a platform where you can create bots, chat with large language models. It's like one subscription to chat with like a lot of, it's like WeChat. It's something that Elon Musk is obsessed with. So it's created by Quora CEO Adam D'Angelo. And today they are launching creator monetization platform. So if you have created a bot on Poe, that makes people sign up for Poe subscription, or somehow if Poe is creating some revenue out of it, you're going to get a share of it. As with so many other things in the world, this is starting only in the US. but at least like it gives you an ability to make money out of your current hobby or something. So very final news of today is a scoop, speculation still, but I saw a lot of people commenting on it, so I thought, okay, let me share this. Sweeping new Biden order aims to alter the landscape. That's a title that I don't understand much, but the point here is that there is a draft executive order that is going to put a lot of new guidelines for the government to regulate the AI market. And I've heard in multiple places, like for example, Technium, who is somebody who I respect a lot, a very prolific fine tuner, and a bunch of others who have tweeted saying that this could actually impact the open source community, because like companies like OpenAI, Sam Altman, who maintains a very good relationship with the state, can go and then tell them, hey, this is what we are doing, we'll sign NDA, our model weights are not going to be released, and politicians are going to be like, oh great, all they need to know is, okay, it's a virus is not going to get out of the lab. That's what they're going to think. And on the other hand, it might sound like, hey, open source models are going to be like multiple viruses that are going to be everywhere. With that kind of an example, or they usually use nuclear energy as another example. The point here is that it seems like the US is coming up with some kind of executive order that is currently in draft. I'm not sure like what is going to happen to it. I'm not sure what kind of implication it is going to set in the other markets, like countries that typically follow the US. But I know for sure, like there are a lot of countries, like for example, China, who are not going to slow down. Definitely, we have seen a lot of interesting papers, interesting models coming out of China, open source, bit of permissive license, sometimes a little bit closed license. We've seen quality models coming from Abu Dhabi, UAE. So I'll wait and watch what is happening in this. Let me know in the comment section what do you feel about the government, especially in this case, US government, regulating the AI industry. Means I've never heard anybody saying that I want to regulate. How do you code? Did anybody tell you, like especially government, tell you that, hey, the number of lines you should use, should you use tabs or spaces, what is the ID you should use, can you release the code or not? I think AI has gathered like that much of large speculation about comparisons with the nuclear weapons or comparisons with viruses and all these things that cannot be contained. So maybe that's why it is happening. I have like good faith in what they think about it. If it is going to restrict capabilities to release open source models, I think that'll be a bummer. So let me know in the comment section what do you feel about this week's AI weekly summary. If you've got any feedback, let me know. Otherwise, see you in another video. Happy prompting.